Good morning, good afternoon, good evening, wherever you may be tuning in from. Jason, we are back. This is episode 62 of Industry Insights. And Jason, let's do a little housekeeping. For those of you watching on LinkedIn, we've been doing closed captioning lately, but if you want to turn that off, it's probably easiest in full screen mode. You'll see the CC button there. You can hit that off. We are tri-casting on 3 platforms. Be sure and check us out. And if you are on LinkedIn live right now, in a comment, give us a shout out where you're tuning in from. We're going to go to the world map here right off the bat. I'm in Colorado. Jason, of course, is in Texas. Our producer extraordinaire is in Georgia. We've got excellent assistance in Romania that's going to be handling the chat and activities there. And Jason, we're talking about containers today, and I figured you could carry the show, but I also have some supplemental assistance if we should need it.
Yeah, I think you're going to need that supplemental assistance, dude. I can barely spell Kubernetes without a spell check wiggle underneath it. So we should really bring in some subject matter expertise on this one. What do you got for us, pal?
Well, speaking of spelling, Kubernetes is more difficult to spell than you might think because Microsoft Teams wanted to override or correct Kubernetes to be rubberneck. And nice. I'm sure there's some connective tissue why that's the case, but I can't answer it. Let's bring in our colleague, Michael Cade from the UK. Michael, tell us how this rubberneck thing came to be, or just tell us about Kubernetes.
I think to help Jason here, and I'm bringing the SME vibe to it, is that you don't have to worry about spelling that whole Kubernetes long word out. Just put K8S. There you go, simple. Now you're an expert.
Yes. Yeah, I don't want to think about what Microsoft spell check would do to K8S, but I'm going to say
no. But yeah, I guess to your point, Dave, so Kubernetes, this has been my world for the last 6 months, but the focus around Kubernetes is a platform that enables better application development, but also just running your systems, it's just another platform that enables a much faster way of developing that application, storing those workloads, and providing scalability orchestration to your containers that are potentially running some state or some stateless workloads, such as web servers. But I think more and more we're seeing over time is around, especially from the CNCF survey, so the Cloud Native Foundation, is we're seeing over 50% of clusters out there, Kubernetes clusters that are out there, are running some sort of stateful workload, be it mostly around NoSQL, SQL databases, but also things like batch processing, messaging queues, etc., RabbitMQ, and things like that. So that's where my focus has been around data management in those spaces, because it doesn't matter whether it's a database in a virtual machine, in a cloud-based workload, in a physical machine, it still needs some sort of protection, right? So that's been my world.
So can maybe start with a primer, though, because one of the things I'm a little curious on, you've had this massive transition in your career path. I always knew you as the storage guy forever and ever, right? A traditional IT pro data center storage guy. And I think there's a lot of us over these last couple of years that had to reinvent ourselves from physical servers to Vert. Kubernetes and containers doesn't look anything like any of that. That in itself is kind of an amazing transition. Talk about that from not only your perspective, but also from the other folks that need to be on that journey as well.
Yeah. So I think I'll go back that 6 months mark, and I spoke to Niraj, like one of the co-founder of Kasten and K10. And I was saying, he was saying, look, you'll be great at it. You've got that technical community, technical content focus. And I was like, yeah, but what about this learning curve? Exactly what you've just said, Jason. What about this learning curve? And I feel like it's too steep. I have no idea. Yeah, I know virtualization. I know cloud. I know physical. I know infrastructure. And I know storage, as you just said. And he goes, it won't be that bad. It won't be that, and he is. If anyone ever gets the chance, if you get Niraj on here, he's super laid back, such a top guy. And so I went into it with obviously the knowledge that I had around infrastructure, around virtualization, and actually there's so many similarities. Forget about. I think this is the easiest thing to do is kind of forget about that app development, because that that does make it daunting. That makes it
Yeah.
scary, because you've got to understand about containers. You've got to understand about, well, what is a container? How does it work? What does it do? Let's just think about the platform. What is Kubernetes doing? Kubernetes is orchestrating some containers. Let's think about containers. I don't really want to do this, but let's think about them as virtual machines for now, just to understand a little bit more about what they are. And think about a container orchestration engine such as Kubernetes. I'm going to move those containers or those VMs around. So I live and breathe virtual machines, virtualization, VMware, vSpheres, vCenter. Well, vCenter is an orchestration engine for your VMs. Okay, that's one tick. Now we've fixed that. Now we think about our containers. Now I'm going to get shot in this new world, in this community of a container is not a virtual machine, because there's so many differences to that. In that, one, it's an abstraction layer of the underpinning operating system. Now, let's go back a bit further and let's talk about, okay, so we've got a container orchestration, but what do these containers live on? Well, they live on something in the Kubernetes world called nodes. Okay, so we've got a node has an operating system, and our containers live on top of that. Okay, what operating system runs what does the node OS need to be running? Is it a particular hypervisor or an operating system such as a hypervisor? No, it's something like Ubuntu. It could be literally AWS BottleRocket, which is their own AWS's own container OS that's like trimmed down to be what it needs to be, just to host containers. Obviously Ubuntu has a broader use case, but a node has an operating system. Now, if we think about ESXi, and again, sorry for all of the Microsoft users out there, Hyper-V, I know, Jason, you come from a Microsoft background, so let's go with the Hyper-V or the VMware approach, is that just think of that as an ESXi host. A node equals your ESXi, or it's the bit where it's the part of the infrastructure where your containers are going to run. And you can have as many of them as you want. You have different flavors of those nodes. So you have something called a control plane, the node formerly known as master, but with the world and what's happening around naming and things like that, let's call it control plane. And this is where purely it's going to look after, it's not going to run any of your containers. It's going to look after any of the input output of your Kubernetes cluster. It's going to be anything that gets requested is going to go through that control plane. And then we've got our workload or our worker nodes, which is where we can have as many of them as we want. And this is purely where the workers or the containers, the pods being the other building block of Kubernetes, which contains a container. I can't believe I just said that. But ultimately, a pod consists of a container or more, but generally speaking, just one container, and that's our workload. Think of that as a web server. And now the orchestration engine is orchestrating those containers to live where they need to in this big cluster of nodes. So again, if you think about that orchestration engine and our virtual machine environment, where vCenter is orchestrating them VMs to live anywhere on the cluster based on whether that's load, like CPU memory, same thing, or whether there's a failure. Those nodes will die just the same as they do in the virtual world. So if it dies, I need to move, or not necessarily in the virtual world, would move the container from host A to host B, or failed host to good host. In Kubernetes, we're not going to do that. We're just going to spin up a new container, because it's that quick. And that's the whole point, is all of it needs to be declarative in state.
Cool. Well, I got to give a quick shout out on Facebook, of all places. We've got our first entry from Iceland, meaning first viewer. So it's always pretty cool to see some things light up here. I see Canada, of course, makes a good part of the map go green. We've also got Ohio, and in addition to Texas and Colorado previously, but New York, Boston as well. And if I look down below over here on the European area, Netherlands, Spain, Ireland, of course, got to mention Iceland again, Germany, France. If I go over a little bit, Brazil, which is always a fan or a favorite of Jason's, as well as Colombia, Mexico, if I was remiss in mentioning them earlier. And then we've got South Africa, Nigeria, and Philippines as well. So a whole lot of activity going on, and thank you very much for that. So Jason, I'm thinking I'm more aligned with you right now. I know we've got a series of 4 graphics. Everything you said, Michael, I I followed, but let's kind of wind us the other direction. And if you could just kind of chat through a bit of evolution, because to Jason's point, there's some stuff that's different for sure. But as you were unpacking this, meaning making the ESXi analogy, there's a lot of concepts that are similar. They're just implemented in a little different fashion.
Yeah. So all of us on the call will remember or even have and manage physical systems, because there's some things that you just can't virtualize or you can't move to the cloud. Maybe it's an IO card that sits in the back of that server, and they haven't gone away. And this is going to be a theme as we go through these slides, is that we've got our hardware, we've got a physical server, a 2U box that lives in a data center somewhere, and on that we have an operating system. Could be Windows, could be Linux, could be an older operating system, or an architecture for that matter. But ultimately, on top of that, we would have our application. Maybe one application, or maybe several. And that's the key part there, is that these are physical footprints of applications that live within your data center. And then if we go to the next one, Dave, and hopefully that you guys will know the physical world. So hopefully
this is old school,
one,
brother.
right?
Yeah, you're back in our comfort zone now, Michael.
So now we go into virtualization, and we go to, I can't remember when this happened, and you guys probably know better than what I do, is around that timeline of when did virtualization come along and change the way we deploy our applications, but more so our workload servers. And this was that first layer of abstraction. And I'm not saying that, obviously virtualization has been around for more years than VMware, and containerization has been around more years than Docker and Kubernetes, just to get that quote in there before anyone else does. But from a virtualization point of view, the fundamental objective there was about abstracting away, or removing that, or consolidating that requirement for so many 2U boxes. Obviously there's bigger U, we won't get into that, but really what this is focused on is that we've still got our hardware. Maybe we've got a lot more hardware. Maybe we've put higher spec CPUs and higher memory. Everyone knows that we need more memory when it comes to virtualization anyway. And then on top of that, we have our hypervisor. That hypervisor then is our ESXi layer, or our Microsoft Windows server, for example, for Hyper-V. Could be AHV as well from a Nutanix point of view, and so on and so forth, our RHV. Then on top of that, we have our virtual machines, and we have as many virtual machines as we possibly can fit onto that. So we're abstracting the layer, the hardware layer that enables us to have multiple virtual machines within that. So the virtual machine doesn't share anything underneath other than the physical system, the CPU, the memory, the storage potentially. But generally speaking, we'll have a shared storage offering. And this is obviously where, from a Veeam point of view, this is where we came into the market. This is where we focused on we didn't think that we wanted an agent to look after these many different virtual machines. We wanted to hook into the underpinning hypervisor and leverage their APIs so that we could take that back up. And that's important to note, because we'll get to that later on when we get to Kubernetes as well, and Kasten K10. But okay, we're all still there, yeah. We're all good, right? That's virtualization. We're good,
except you misspelled virtualization. I mean, other than that, I think we're fine. So
I think there's a huge argument we can go down here, Jason, but we won't. For the good of the viewers, I think it's fair to say that I've spelt that correct from where I'm sat right now. But if we go to the next slide, this is where we then start introducing cloud. So this is where we start to see infrastructure as service, or potentially RDS. And think of these as just further abstraction layers. With virtualization, we still manage, we manage the underpinning hardware. We still have access to that 2U box that is running ESXi, and we can go to it, and we can see it, and we can look at it. Whereas when we go to the cloud, that's not necessarily the case, because we're now abstracting the management layer away from us. So we still get our operating systems, we still get our application servers, we still deploy that, and then as we move up the stack to things like database as a service, RDS within AWS, for example, we're just removing the operating system. There's an operating system somewhere, but you're just taking it, it's being abstracted away from you to have to manage it. Obviously you pay for that, but it's about convenience, it's about manageability, it's about administration at that point. So now we've got physical as an option, and physical might work because of IO cards. We've got virtualization because that's really focused on consolidation of hardware, as well as all the other benefits that come with that. And now we've got cloud, whether that be the public cloud, the hyperscaler such as AWS, Azure, Google, but also managed service providers as well. Like all of our, I'll quote that, our VCSPs, they have the ability to offer some sort of infrastructure as service, no doubt. So where you go and roll your own virtual machine, they'll look after the physical servers, they'll look after the input output type thing, they'll look after potentially the operating system, and you just have a service where you just consume it and you pay monthly, and you have that as one of your application servers within your business. And so we've got that as another choice as to, well, where does our workload strategy take us? Where do we go? And a lot will come down to understanding, some will come down to skills, and some will come down to like being told what to do, depending on what position you are within the company. So then we go on to another option, another overwhelming option, which is the next slide, around containers, I believe. This is me guessing the slide.
Yeah, this is the scary one, right? So, I mean, we're all comfortable with, we abstracted the hardware, we're comfortable with virtualization, and it seems like this is the big leap. This is where we go from I'm an IT guy to DevOps, PlatOps, XOps, right? Spec Ops. I mean, this is the scary one. Break this one down for us, man.
Yeah, so exactly that. So you hit the nail on the head with the first word I think you said was around abstraction. So a container is just another form of abstraction. So we abstracted the hardware with virtualization. We abstracted some layers of the management focus within cloud. And with containers, we're focusing on abstracting the operating system. And we're providing the operating system of the node. So here we see a node or 3 nodes. And above that, we have a container that shares the underpinning operating system, the node's operating system. So where a virtual machine can be a completely separated, so I can have ESXi running, and then I can have an Ubuntu VM, I can have a Red Hat Enterprise Linux box, I can have a SUSE box, I can have a Windows Server 2022 box, I can have a Server 2019, you name it, and they're all segregated, they're all isolated away from each other, they're not reliant on anything underneath other than the CPU, the memory, and the functionality of that hypervisor. When we get into containers, they're very much reliant on that operating system, that Ubuntu box, that Ubuntu operating system, which has its constraints as well, because if you've got containers that need to run on a certain flavor of operating system, well, then I need a node for Ubuntu and I need a node for Windows. Yeah, there are containers out there that live and breathe on Windows as well. But really, it's about that abstraction layer up the stack. And now these containers, so where a virtual machine is multiple gig, sometimes more, a container should be in the megs. So then that incorporates the ability to be very mobile. Now, I'm a massive fan of Veeam backup replication around our portability messaging, about being able to help you move a virtual machine from A to B and potentially back to A again, or then off to C, based on whatever that needs to be based on. So whether it's a failure scenario, whether it's cost, whatever that may be. But we've still got to rely on the laws of physics. If we've got a 100 gig virtual machine, we've got to get that virtual machine and all of the blocks of data from A to B. Now, that's going to take some time. We could have the fastest internet in the world and the fastest uplink over in the destination that we're sending it to. We're still relying on 100 gigs of data to go from A to B. When it comes to containers, we're now talking megs of data. So I can develop something on my laptop and I can get that up into a Kubernetes cluster within AKS or within AWS super fast. Like as fast as you can move or stream a song from Spotify or whatever music streaming service you use. But really it's about speed, and that then lends itself to application development, but also about hosting your applications. So today we don't generally see the big like your day-to-day applications that you run within your data center. They're generally going to come on an ISO and you deploy them on an operating system of your choice or of their choice that they support. So you download the ISO, you install it, job done, you then off you go. From a container point of view, and I strongly believe this is coming in years to come, less years potentially, is that those mainstream applications are going to become containerized and we're going to deploy them. Now, it's happening already. Now, this is the first part, is that we can absolutely just have a container or containers running on a node in our data center, in the public cloud, wherever we want that to be. But where we lose out here, and this is a bit like running, and I'm purposely dropping in the likening to virtualization here. So from an ESXi point of view, VMware or anyone, you could absolutely go and deploy, or you could take a physical machine, physical server, and you could go and install ESXi, and you could go and put 10 VMs on that, and it would work, absolutely work, and it'd be great until that box dies, until that box no longer boots up. And then all of the VMs that are on that are also not working. And then that's when a container orchestration engine or a virtual machine orchestration engine comes in, such as vCenter, where it can pull many ESXi servers together and enable you to move freely those VMs wherever they need to be. So a container orchestration engine does exactly the same.
Cool. So I do want to give a shout out. Please tell us where you're tuning in from, and also give a shout out for any questions you may have. Had a couple comments come in that we've replied back to. So I think we've kind of broken down a little bit containers, Kubernetes in particular, how it's different, but how it's also not so different. And I like where you're headed, Michael, and you're getting closer to the world Jason and I live in, which is when things go bad. It's all good until it's all bad. And so now let's shift gears a little bit and talk to us about Kasten, maybe in terms of what the product does, but also kind of your learning journey going through this evolution.
Yeah, so actually the learning journey for learning about Kasten was pretty quick. But let's rewind a bit before we get to that, is that so data management, obviously that's what we speak about here at Veeam, about protecting workloads, protecting data. The challenges from a Kubernetes point of view are still the same as what we see within virtualization, within unstructured data, within cloud, is that failure scenarios still happen. Accidental deletion, top of the list, but also things like ransomware, malicious activity, etc. It all still happens. So that was the point. That's the reason for Kasten K10. But then on top of that, for those that know Veeam backup replication, I mentioned it at the top around focusing on leveraging on the hypervisor APIs and being able to take those fast, efficient backups without an agent and the overhead of that agent management. Kasten K10 is deployed within your Kubernetes cluster as a native API operator or a construct within that. So it lives and breathes the same stuff as your applications. But also there's two sides to that. So on the slide, you can see that this is the dashboard. So as a platform operator, regardless of whether that's VMware, I want a UI. I want some sort of UI that allows me to have visibility of my backups or my policies. I want to have a visibility of what my data looks like and how it's growing, and have some sort of visibility of change rate, etc. And then I also want to be able to set and forget my policies in here and perform recovery tasks. But the nature of it being inside of the Kubernetes API gives us another capability in that it means now that everything that you see in the UI is API driven. So everything that is there and available to Kasten is also within the native Kubernetes API, which means you can drive a lot of that functionality, all of that functionality, from a DevOps perspective. So you can automate the creation of policies, and all the way through the UI, there's little breadcrumbs that give you the hints that you need to be able to take that, automate that, and put it into your CI/CD pipelines. And I don't want to get into too many of the other words and the other areas around that make up this application development and DevOps space, but it's really focused around being the choice of being able to leverage and want to use the automated approach for data management, but then whilst also having a UI for the platform ops and the SRE. The DevOps and the developer are going to prefer to do everything in a code-based type fashion or a GitOps type model. I won't use any more buzzwords.
No, yeah, there you go. Yeah, if we're playing buzzword bingo at home, maybe we also have to just mention polyglot at least once, even if we don't define it, because then we'll get a trifecta. So this is making sense. Jason's closer to our world now. It's backup and recovery. It's application mobility. Near and dear to your heart always, J Buff, has been disaster recovery.
Amen on that.
As we begin to land the plane, take us through the slide that kind of decomposes all the many things that K10 supports, meaning for a product that's relatively young in market, meaning not a decade, there's a lot of stuff that's already covered.
Yeah, so I think the three higher level pieces that we play in from a Kasten point of view, but also this spans over to Veeam in general, right, is that backup and recovery is generally the first thing that we have to talk about. Backup, table stakes, I want to be able to move something from A to B, but I also want to make sure that things are consistent, and that's where the data services come in. So whether that be a MySQL database, whether it be in particular, my favorite here is around Amazon RDS. So taking an external data service and attaching that to your Kubernetes application, and Kasten K10 has the ability to protect all of that with one policy. But those data services, first and foremost, backup and recovery of being able to be able to handle that. Second is around disaster recovery. So fire, flood, blood, they all happen regardless of whether you're running Kubernetes or VMware or Hyper-V or you name it, or AWS or AKS, and you name it. The platform is there's a potential for disaster. There's a potential for failure. Kubernetes doesn't have that have any secret sauce that stops you getting that problem. So from a K10 point of view, not only do we want to be able to send those applications, that application centric approach that we have, send that to a different location, but we also want to be able to automate that process, but also automate our own. So K10 lives within the same cluster that you're protecting. So we want to be able to send that as well to a different location. So that's there as part of the second ticket item, if you will. Then the third is around application mobility. How can I take my application that is hosted in Kubernetes, let's call it Kubernetes A, and how can I push that to Kubernetes B? So whether that's AKS to EKS, or so AWS to Microsoft Azure or Google or on-prem. Like, we've got the ability to transform what that manifest looks like, what that application looks like when it lands from A to B. So that's very important here, is that, so from a data service point of view, we've got the ability to go application consistent and provide that ability to take a good consistent copy of that. From a distribution point of view, there's many distributions of Kubernetes. So we've got the ability to integrate into many of those, with more coming from a validated support point of view. The container orchestration engine of choice that we support is Kubernetes. Now, there are other container orchestration engines, but namely, we're seeing that Kubernetes is flying above the rest. So against things like Mesos and Nomad and others out there, Kubernetes is definitely winning that battle. But then also there's a lot of choice around the storage infrastructure underneath, whether you're using cloud native storage like under Google Cloud Storage, or whether you're using other on-prem solutions such as NetApp or Dell EMC or Pure, all of them being options. But then also, where do you want to store that data? So whether it's, again, in the public cloud, in object storage, whether it's any S3 compatible, the Cloudians, the MinIOs, etc. Also, though, being able to store those into a bring your own NFS storage share, or, which we've got coming, is the ability to store those backups into a Veeam backup replication repository. Like if you're running both virtual, physical, cloud, and you want one central location, and you're also running Kubernetes, you're going to want to protect them and put everything in potentially in one place and manage everything in one location.
Perfect. And for those that want to kind of learn a little bit more, we've been sprinkling out a URL that talks a little bit about the Kubernetes cloud native journey in the DevOps world, but also take us really quickly. This URL code, this is intentional or is quick code?
Yeah. So not everyone's got access to the public cloud. Everyone has access to their laptop, but generally and you can run things like Kind and you can run things like K3D. But let's not get into that. But if you can and you've got the skills to be able to do that, then great. There's a free copy of K10. So here I'm looking at number 2, so on the right-hand side. So as with Veeam, with every product that we have, there's a free edition. That's going to give you the ability to protect 10 worker nodes free forever. So great for our home labs, our learning journeys, being able to deploy, spin up, spin down. One of my key things has been around making sure that you're playing with kubectl on a daily basis, which is the CLI to Kubernetes. Be in there, learn what it is, learn about YAML files. Anyway, then we're going back to number 1. Not everyone has access to a cluster. Not everyone even knows how to get into Kubernetes and start deploying. So we've made a Kasten K10 test drive, which, spoiler alert, it's just an automated way of being able to provision a Kubernetes cluster. You don't have to worry about doing it the hard way. And underneath, yes, some of the steps are Kasten K10 focused, but this gives you an automated Kubernetes cluster where you can go and learn that. And it's completely free. It's not going to stay around forever, so don't put your production web servers on there or anything. But it's going to walk you through the steps to get to grips with deploying a data service, deploying and protecting that data service with Kasten K10. So lots of steps on there, and I'll give you, everyone on the call, I'll give you a heads up that there's something coming that takes the step further. So know that there's more emphasis around learning. We're all at different parts of our learning journey, and we think that we can help, very much like Veeam helped me when I was going for my VMware VCP, and we think that we're in a position where we can help us as platform operators, people that look after virtualization areas, be able to upskill you into at least have that understanding of Kubernetes. Not very many people are going to be Kubernetes admins tomorrow or next week or potentially in the next year, but the awareness is probably going to be the foundational knowledge is going to be king. That's really that QR code will take you to, in fact, that's going to take you to a link that takes you to the hands-on lab, but also to where you can get started with K10 as well.
Dave's on mute.
Yeah, double mute. Got the dreaded double mute going on today. Well, thank you, Michael. Hey, we really appreciate you rocking us through containers and Kasten in particular. So we look ahead this Friday, I believe, and there's some discussion on this, but I believe we're going to have Rick Vanover, Melissa Palmer double click on ransomware remediation. Edwin Weidema and I are going to tick up that same topic from a past poll we did last month looking at Veeam. Today we looked at Kasten. Next Monday we'll look at Veeam and ransomware. And even though it's early, Jason, I want to give a shout out to a 3-part series in the month of September that you and Melissa will do. Tell us about that.
Yeah, so in September, when we're talking about disaster recovery as a 3-part series, September is the right time of frame to look for that, because as you start looking towards your 2022 plans, you got to get it into your budget. And so let's talk about what you should be doing around disaster recovery as a 3-part series. Melissa Palmer is a fantastic rock star in that, and she is our guest for the month of September.
Outstanding. Well, thank you everyone for tuning in. As we sign off and you view later on, please do put comments in where you are tuning in from. Thank you all. Stay safe, stay positive, and we will see you on the next live stream.